Okay, so we're going to continue by focusing a little bit more specifically on right triangles again. Okay, so we're going to move away from the coordinate plane and directly into right triangle trig. So this question says, let theta be an acute angle of right triangle. So we're only worried about angles that can fit inside of a triangle. Find the values of the other trig functions of theta below. So they gave us one. Cosine of theta is equal to 10 over 13. We're asked to find sine, secant, and cotangent. Now, before we even draw any right triangles, there's something we should see right away that can make our life a little bit easier. And that is the reciprocal of cosine is secant. So without even worrying about the triangle itself, we can just immediately write that secant is equal to 13 over 10. Okay? So we have 1 out of 3 done. So now let's draw a triangle. What does it mean to have cosine equal to 10 over 13? Well, if we are on a triangle, right, we have a right angle, we have a theta, and cosine is 10 over 13, that means my adjacent over my hypotenuse is equal to 10 over 13. So my adjacent side, remember, is always the side attached to the angle that's not the hypotenuse. So that's 10. My hypotenuse is always my longest side or opposite our 90-degree angle. So that's 13. So all that's left to find is our opposite side, right? So do we need our opposite side for any of the trig functions left? Well, unfortunately we do. So we're going to have to calculate using the Pythagorean theorem. A squared plus b squared is equal to c squared. So we have 10. We don't have the other opposite side. And we have 13. Okay, so 100 plus x squared is equal to 169. Subtract 100 from both sides. We get 69. Square root both sides. X is equal to a plus or a minus radical 69. Now, radical 69 does not reduce. It has no perfect square factors. Okay, but we do have to decide whether we're going to take the positive value or the negative value. Now, in a triangle, all the angles are going to be positive, so we don't have to worry about the negative value here. So x is equal to radical 69. So let's find the rest of these trig functions. So sine is opposite over hypotenuse. Well, that's radical 69 over 13. Nothing to be reduced. What is cotangent? Okay, cotangent is the reciprocal of tangent. So opposite over adjacent becomes adjacent over opposite. So what is my adjacent? 10. What is my opposite? Radical 69. I have a radical in my denominator, so I have to rationalize. Oops. So we get 10 radical 69 over 69. And I don't believe that can be reduced. Okay? So anytime they give you a cosine or a sine or a tangent or any trig function, you can set up your own right triangle and use those ratios that we should know really well at this point to find the other trig functions. Okay, so what else can we do with these right triangles? Well, we can also use them to find an indicated angle. Okay, so we're looking for this angle up here. We are given 12 and 17 on those sides. How do we do this? Well, remember, anytime we're finding an angle, we need to use the inverse trig function. Okay, so we need to find which inverse trig function works best for the sides that I am given. So if we label this, right, 12 is the opposite side from my angle. 17 is my hypotenuse. So which trig function relates opposite and hypotenuse and also has a button on our calculator? The answer is sine. Okay, so sine of this theta is going to be equal to 12 over 17. So how do we find the measure of the angle? Well, we must use our inverse trig function. Okay, so if we type this into our calculator, we should get that this is equal to 44.9 degrees, as long as your calculator is in degrees. And because we are working with triangles, we're going to stick with degrees. Okay, radians we tend to use when we're on the unit circle and the coordinate plane. Okay, what else can we do with right triangles? Well, we can just be given different pieces of information, right? So now instead of trying to find the measure of an angle, we have to find the measure of a side given a side and an angle, okay? So we look at this 55. We are given our hypotenuse. What is the piece of information we are trying to find? Well, this side is attached to my angle, so this would be my adjacent side. So because we're given an angle, we're going to use the trig function that relates adjacent and hypotenuse. Well, the one that has a button on our calculator for this is cosine. So cosine of 55, and I'm actually going to bring this up. Cosine of 55 is equal to the adjacent side over my hypotenuse of 20. So how do I find this x value? Well, anytime we're given something like this, my suggestion is to turn into a proportion. If you can cross multiply, you can solve for the value of x. So I would get 20 times cosine of 55 is equal to x. Now you want to be extra careful, okay? Because you want to make sure you are in degree mode. Otherwise, you will not get the correct answer, okay? My calculator is in degree mode, so I type it in and I get that x is equal to 11.5 approximately, okay? So the measure of this side is 11.5. Okay, so we can use trig functions to identify all the parts of our triangles. Okay, so now what's left for us? Well, what are some applications? And believe it or not, trig applications are probably the most used. Those of you taking physics already know this, okay? But to do that, we need some vocabulary words. So 2 vocabulary words. Now, all the questions won't necessarily mention these, but a lot of them do, and they're called the angle of depression and the angle of elevation. What's the difference? Well, it depends on your perspective. Okay, the angle of depression is an angle measured down from a horizon or a horizontal line. Okay, looking at the diagram we have here, we have a ship and we have a plane. The angle of depression would be as if you were standing on this plane, right? And you were looking down on the ship. Okay, the horizontal line is in line with your eyes, okay, and your view is this diagonal to the ship, okay, whereas angle of depression would be looking up from a horizontal line. So that would be as if you were on the ship and you were looking up at the plane, okay. The horizontal line is usually the floor of some sort, and again, the diagonal is going to be your line of sight. Okay, so if we wanted to apply this to a word problem, let's give it a try. A ski slope at a mountain has an angle of elevation of 25.2. We're snowing, so let's use some snowy colors. The mountain peak is 1808 feet high. How long is the ski slope? So let's draw this picture. We have a mountain, a treacherous mountain. Okay, the angle of elevation would be if you were to be looking from the base of the mountain up to the top of the mountain. Okay, so I'm actually going to draw that closer. Okay, this right here is our angle of elevation, and that is 25.2. Now, the mountain peak is 1,808 feet. Well, that's measuring from the base of the mountain. So if we drop a altitude here, measuring the height of the mountain peak, we get 1808. So the question is, how long is the ski slope? Okay, we want to find the length of the ski slope. So looking at this picture, is this the length of our ski slope? No, that is the length from you to the base of the mountain. So our ski slope is where we are actually skiing down, right? This is a person on skis, screaming, ah! Okay, wearing a helmet, of course. The ski slope is the distance that they are traveling from the top to the bottom. Okay, so if we look according to the angle of elevation, 1808 is our opposite side, and the ski slope is our hypotenuse. So we're going to be using sine. So sine of my angle, which is 25.2, is equal to 1808 over x, the distance. Now, this one's a little different, right? The x is in the denominator. But if you can solve a proportion, you can solve this. So if I cross multiply, I get x times sine of 25.2 is equal to 1808. Okay, now I still need to isolate x, so I'm going to divide by this trig function. Okay, and I get x is equal to whatever this is when plugged into my calculator. So, again, make sure your calculator is in degree. And type it in, 25.2, okay, and we get 4246.3, and that would be feet. Okay, so the distance you're going to travel down this mountain is 4,246 feet approximately. Okay, let's try one more. The angle of depression from the top of the lighthouse to the boat is 25 degrees. If the boat is 50 meters from the base of the lighthouse, how high is the lighthouse to the nearest meter? Let h represent the height of the lighthouse in meters. Well, keyword here is angle of depression. Remember, angle of depression is looking down from a horizon. So imagine that you are here at the top of the lighthouse looking down at this boat, right? Our horizon is this distance across. And my angle of depression is this x degrees labeled right there. Okay, so that is 25 degrees. Now, if the boat is 50 meters from the base of the lighthouse, well, that means from here to here is 50. Well, we have some trouble here because that's not where my angle of depression is. Well, if we think about this as a rectangle, right? That 50 degrees that matches the base to the boat also matches from the top of the lighthouse to an area directly above the boat. So we have 50. Now the question is, how high is the lighthouse? So again, the lighthouse is here on this side, matches on that side. Okay, so we are trying to find the height of the lighthouse. Oh wait, they use h. Okay, so what trig function compares this angle to, let's see, the height is our opposite side, and 50 is our adjacent side. That's tangent. Okay, so tangent of 25 is equal to our opposite over our adjacent. We cross multiply, we get 50 times tangent of 25 is equal to h. And we get h is equal to 23.3, so 23 meters high. Okay, so that's the height of our lighthouse.